Can you hear me?
Yes, sir. Yes, sir.
Okay. So let everyone come and join the meeting. I hope some of the students are still left. Okay, so please tell me in the last class what we have discussed. I think we have discussed the properties of concrete. Hello?
Yes, sir.
Okay, so please tell me last class means up to how much we have discussed.
We did up to RCC.
CC means properties of concrete is over or something is still left. Properties of concrete. I hope we discussed the properties of concrete in the last class.
Yes, sir.
Okay, so up to how much it is completed? Okay, up to how much? Can you tell me the properties which we have discussed in the last class?
Sir, we did batching.
Okay, so up to batching means characteristic strength, then shrinkage, creep, everything is done. Shrinkage of concrete, then creep of concrete, then
No, sir. No, sir.
huh? Shrinkage of concrete, is it done? Hmm?
Did batching, then PCC, RCC, and third.
No, I am asking about the properties of concrete. Did we discuss the properties of concrete or not? I think I have given the properties of concrete also. Characteristic strength. Did we discuss characteristic strength or not? Hello. Did we discuss characteristic strength or not? Just tell me that one. Hmm? Yes or no? If you don't say anything, then how can I know that how much we have discussed in the last class? I am asking you whether we have discussed characteristic strength or not. Please tell me. Hello. Please tell me. Someone, anyone,
No, sir.
who has attended the last class. Benison.
Sir, checking.
Okay,
Sir, no, only RCC and PCC.
so we didn't discuss the properties of concrete.
No, sir. We
Okay.
discussed the composition of action of steel and concrete in RCC.
Okay. Okay. So now I will share my screen. Okay. If you can see it, you tell me. Huh? Okay. So can you see the screen? Can you see the screen?
Yes, sir.
Yes, sir.
So now let us discuss the various properties of concrete. Okay. Okay. So if you want, I can share you the PDF also. But now I will try to explain the things. Okay, and if you have pen and paper with you, you can write down the points also. Okay, because in this PDF everything is very briefly described. Okay, so I will try to explain all the terms. Then if you have pen and paper, you can write it down. Okay. Okay, so let us start the properties of concrete. Okay, so I hope you can read the PDF properties of concrete, whatever it is written. I hope all of you can read it. Okay, so let us start with the characteristic strength of concrete. Okay, so as it is defined, that it is defined as the strength below which not more than 5% of the test results are expected to fail. Okay, so what is the meaning of that? That means if we are making a concrete M20 grade of concrete, okay, so what is the ratio of M20 grade of concrete? Can anyone tell me what will be the ratio of means cement, sand, and coarse aggregate in M20 grade of concrete? Can anyone tell me?
1:1:2.
1 is to, I am asking M20 grade of concrete. Can you tell me? Okay, the ratio is 1 is to 1.5 is to 3. For M20 grade of concrete, the ratio is 1 is to 1.5 is to 3. That means if you take 1 part of cement, then you have to take 1.5 part of sand, and you have to take 3 part of coarse aggregate. Then only you can make a, and if you add water in sufficient amount, means required amount, then only you will get M20 grade of concrete. That means after 28 days of curing, if you test that cube in a compressive testing machine, then you will get the strength of approximately 20 newton per millimeter square. Okay, so now characteristic strength means if you are taking an M20 grade of concrete, so after 28 days you must get the strength of approximately 20 newton per millimeter square. Okay, I think all of you know that. Is it? Okay, so now characteristic strength means if you make 100 cubes of M20 grade of concrete, and after 28 days of curing, if you test those 100 cubes in M20 in that compressive testing machine, then at least 95 cubes must give you the strength of 20 newton per millimeter square. Okay, so that is known as your compressive strength. If more than 95 cubes will give you the required strength, that means your 20 Newton per millimeter square, then you can say that that concrete has a characteristic strength, compressive strength of 20 Newton per millimeter square. Okay. Okay, you can read the PDF also. Everything is explained in detail in that PDF. So concrete is graded on the basis of characteristic compressive strength of 150 millimeter size cube. That means the cube which we will make, it will be of size 150 millimeter. That means the size of the cube will be 15 centimeter. Okay, so after preparing that concrete in the ratio, in the desired ratio, say 1 is to 1.5 is to 3, we have to keep that cube for 28 days. Okay, and then after 28 days we have to test that cube in compressive testing machine. Okay, so whatever value you will get, your value will be approximately 20 newton per millimeter square. So that value will be known as your characteristic compressive strength. Okay, so in this subject we will indicate characteristic compressive strength by the letter FCK. I think you can see in the PDF also, F suffix CK. All of you can see it, I think. This value FCK. Can you see this value? Benison, can you see it? FCK?
Yes, sir.
Yeah, okay. So in this syllabus, we will indicate characteristic compressive strength by this symbol FCK. Okay. So if you are making a M20 grade of concrete, then can you tell me what will be the value of FCK? Can you tell me what will be the value of FCK? Can anyone tell me if you are making a M20 grade of concrete, then what will be the value of FCK? Benison, can you tell me? Okay, so it will be 20 only. The value of FCK will be 20 Newton per millimeter square. If M20 grade of concrete is using, then you will take FCK value will be 20. If you are taking M30 grade of concrete, its value will be 30, like that. Okay, so it is based on the grade of concrete. Okay, so next, see this other strength of concrete. Okay, so now do you have this one IS 456 2000 with you, all of you? Do you have IS 456 with you? In the last class, I told you so many.
Yes, sir.
Yeah. Okay, so now then go to clause number 6.2.2. This clause number, which is written in the PDF. Go to clause number 6.2.2. Go to clause number 6.2.2. So if you go to that clause, you can see there is a formula given. There is a formula given. Tensile strength of concrete. Can you see in the book, in the PDF? Can you see the formula? I think it will be in page number 16. Can you see the formula?
Yes, sir.
Okay. So FCR means it is the tensile strength of concrete. Okay. So tensile strength of concrete equal to 0.7 into square root of FCK Newton per millimeter square. Okay. So with this formula, we can find out the tensile strength of concrete. Okay. So now, say in exam, you have a question that for M20 grade of concrete, what will be the value of tensile strength? Then can you find out the value, all of you? Can you find out the value? Say in your exam, you have a question for M20 grade of concrete, what will be the tensile strength? So can you find out the value? You try to find out and tell me the answer. I hope all of you have pen and paper with you. So find out the value of tensile strength of concrete for M20 grade. For M20 grade of concrete, find out the value of tensile strength. So what will be the value? Please tell me what will be the value?
3.13
3.13. What will be the unit?
Newton per millimeter square.
Huh? Newton
Newton per millimeter square.
Newton per meter square or millimeter?
Millimeter square.
Yes, Newton per millimeter square, not meter square. Okay, not meter square. Newton per meter square will be your Pascal. Okay, if you write down Newton per millimeter square, then it will indicate Pascal, and in that case, it will be wrong. Okay, so how did you find out the answer? Can you tell me how did you find out the answer? Shirodhar?
Since it is M20,
Yeah.
compressive strength will be 20, so FCK value will be under 20.
Uh-huh. Yes. Just put the value of FCK as 20, you will get the answer. Okay. Similarly, for M30 grade of concrete, what you have to do, you have to just put the value of FCK as 30, then you will get the answer. Okay. So from the characteristic compressive strength, you can find out the tensile strength of concrete also. Okay. So let us see the other one. Okay. Next, you see elastic deformation of concrete. Okay, so now you go to formula, this one, EC equal to, you see this formula, EC equal to You see that formula? I hope you can see the formula. 1.2, you can see the formula EC equal to 5000 square root of FCK. So EC means your modulus of elasticity. Okay, modulus of elasticity of concrete. This suffix C indicates C for concrete and E for Young's modulus or modulus of elasticity. Okay, so similarly we can find out the modulus of elasticity for concrete also from the value of characteristic compressive strength. Okay, so so in IS code you see the formula in page number 16, clause number 6.2.3.1. You can see the chat box. I will write down the clause number. Clause 6.2.3.1 in the same page. Okay, in the same page, page number 16, go to clause number 6.2.3.1. The modulus of elasticity of concrete can be written as, the formula is given in IS code also. I hope all of you can see it. Can you see the formula in that IS code?
Yes, sir.
Okay, so from this formula also you can find out the elastic modulus of elasticity for concrete. Okay, so now can you find out the value of EC for M30 grade of concrete? Can you find out the value? You find out the value and tell me the answer. For M30 grade of concrete, what will be the modulus of elasticity? For M30 grade of concrete, what will be the modulus of elasticity? Find out. Did you get the answer? For M30 grade of concrete, what will be the value of modulus of elasticity?
27386.1.
What will be the unit?
No unit.
No unit.
No. Newton per millimeter square.
Yes, Newton per millimeter square. If you don't write anything, then it will be wrong. Okay. So E unit will be the same unit of FCK. Okay, Newton per millimeter square. Okay, so after getting these values, let us go to the next property of concrete, which is known as shrinkage of concrete. Okay, so shrinkage means it is the loss of moisture content from the concrete. Okay, shrinkage means loss of moisture content by evaporation from concrete. Okay, if you lost moisture from the concrete by evaporation, then what might happen? That the water whichever is present during the casting, we might lose that water due to evaporation, and as a result of that, within the concrete some voids will be generated, and because of those voids, some cracks might develop on the surface of the concrete. Okay, so what we have to do, we have to avoid that loss of moisture content from concrete. And how can we do that? Can anyone tell me how can we prevent the loss of moisture from concrete? Any one student, can anyone tell me how can we prevent the loss of moisture from concrete? Can anyone tell me how can we prevent the loss of moisture from concrete?
Sir, by applying coating the
By
surface,
applying coating. What kind of coating you will apply?
like color.
Huh? Yes? Okay, then any other answer? Anyone? Shiroda, any answer?
So something that will protect from the sun's rays, or
Yes,
will
then
not
how can we
heat up the
prevent that?
walls.
How can you prevent?
Sir,
Every day you
it
can
will
see that. Everywhere you can see that. How can?
sir it will not So the drying rate will be slower. I mean,
Yeah,
the rate at
but
which
but
the
but how? I am asking you, how can you do that?
hmm, don't know, sir.
Okay, have you seen the construction of a slab in any building? Have you seen the construction of a slab in any building or beam or column? Can you see the construction of any beam, column or slab for any building?
Yes, sir. Yes,
Okay,
sir.
so just after the construction, what we generally do?
We store water.
Yes, yes, yes. Why we store water in that case? Why we store water? Why we put water for some time? Means for a slab, we generally keep it for 28 days or 21 days. Why?
I think,
To
sir,
in
to let the
of
uh,
moisture.
To let the
In order to prevent loss of moisture and
yeah,
so that the
yes, yes,
concrete gets
yes, 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 yes. In order to avoid the loss of moisture, if you don't put water in that slab, then what will happen? Because of sun, we might lose the amount of water which is present in the concrete, and as a result, voids will be generated within the concrete, and because of those voids, what will happen? Cracks might develop on the surface. Okay, so to
Sir.
yes, yes.
Sir, my friends are texting me. They said, will you please allow them to enter the room? They lost connection, so they had to get out.
Okay, okay, wait, 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 wait. Wait.
Okay, sir.
Okay, okay, I will let them. Tell them to connect again. Huh? Tell them to connect again. Yeah, three participants are waiting. Okay, so I hope no one is waiting now. Okay. Okay, so from next class you try to join earlier, okay? Because it is already half an hour gone. Okay, from next class after half an hour, so I will not let you in. Okay. So in the last class also, I think I told you. Okay, so from next class, please be sincere and you try to join within 15 to 20 minutes. Okay, all of you. Okay, so let us continue our discussion. So we are discussing about the shrinkage of concrete. Okay. Okay, so the shrinkage of concrete. Okay, so concrete. Okay, you can, if you want, you can write down one line. Concrete shows shrinkage due to loss of moisture content by evaporation. We can write down one line. Okay, concrete shows shrinkage due to loss of moisture content by evaporation. Concrete shows shrinkage due to loss of moisture content by evaporation. Then you can write down another one. Shrinkage also causes strain in concrete. Shrinkage also causes strain in concrete. Next, you write down one line. The shrinkage strain mainly depends upon the amount of water present at the time of casting. The shrinkage strain mainly depend upon the amount of water present at the time of casting. Okay. Okay, so now you can
And
is
the
casting.
yeah, in the at the
casting.
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 Yeah, casting, casting. The shrinkage
Okay.
mainly depends upon the amount of water present at the time of casting. Okay, so now you go to IS code. Okay, Go to clause number 6.2.4. Same page. Page number 16. Clause number 6.2.4. Can you see that heading, shrinkage? Can you see the heading, shrinkage,
Yes.
of you?
Yes, sir.
Okay, so you see the clause. Okay, so in the clause number 6.2.4.1, in the same page, you can see in the absence of test data, the approximate value of total shrinkage strength for design may be taken as 0.0003. Can you see in the S code? Can you see the value?
Yes, sir.
Okay, so these values with a pen. Okay, so if you downloaded the PDF, you can mark those values. You can highlight those portions so that during exam time, when you go on revising the PDF, then you can see that value. Okay, in the absence of test data, the shrinkage strain is taken as 0.003. Okay, this value you have to remember, 0.003. You can highlight it in the PDF also. Just select the value, right click with your mouse, then you can see highlight text. Okay, highlight text, then you click that highlight text, then it will be highlighted, then that portion will be highlighted in that PDF. Okay, I hope all of you can do it. In the PDF, important portions, you highlight the important portions. I will tell you in the corresponding respective classes. Whenever I will give you some clause, some values, you just highlight that in the PDF, because we are going to use that, and in exam also you might find some questions from those clauses. Okay, so let us see the next point, creep of concrete. Okay, creep of concrete, again you can see in the IS code just below the shrinkage, clause number 6.2.5. in the same page you can see creep of concrete is written. I hope all of you can see the value. I hope all of you can see that part, creep of concrete. Okay, so
Yes, sir.
can you see the creep of concrete in IS code, clause number 6.2.5, just below shrinkage?
Yes, sir.
I hope you can see it. Is it? Hello, can you see?
Yes, sir. We can see.
Okay, so if you want, you can write down 2 lines about creep. Do you want to write? Hello,
Yes, sir.
do you want to write 2-3 lines about creep?
Yes, sir.
Okay, then write it down. Write down, creep is caused under sustained loading. Write down, creep is caused under sustained loading.
Yes, sir.
Next, write down, it is seen that when concrete is subjected to sustained loading, it is seen that when concrete is subjected to sustained loading, comma, strain keeps increasing with time. Strain keeps increasing with time. Strain keeps increasing with time. Strain keeps increasing with time.
So can you repeat once again, sir?
Okay, first line is creep is caused under sustained loading. Okay, next, it is seen that when concrete is subjected to sustained loading, it is seen that when concrete is subjected to sustained loading, strain keeps increasing with time. Strain keeps increasing with time, even without any increase in the load. Even without any increase in the load.
Sir, without any increase in the.
In the load. Without any
Okay.
increase in the load. Next, write down. This strain, which is caused due to sustained stress, this
This.
strain, which is caused due to sustained stress, this strain, which is caused due to sustained stress, and which is time dependent, is known as creep. This strain, which is caused due to sustained stress and which is time dependent, is known as creep. Is known as creep. Next, write down. It depends upon the following factors. It depends upon the following factors. Number one, stress level. It depends upon the following factors. Number one, stress level. Number two, age of the loading. Number two, age of the loading. And number three, duration of loading.
Sir, it's H or ADG or EDG, right?
Age, age.
Okay.
Age of loading.
Okay, sir.
Yeah. And number three is duration of loading.
좀 잠깐만 좀. 아마 좀
Okay, so I hope all of you can write it. It depends upon the following factors. Number one was stress level, number two, age of loading, and number three, duration of loading. I hope all of you have written it. Okay. So all of you do one thing. You write down your name and enrollment number in the chat box. Name and enrollment number in the chat box. Name and enrollment number in the chat box.
Hello, sir.
Yes.
Oh, the class over.
No, it's not over. Wait. I just give you the attendance, then I will continue.
Oh,
It's not over.
okay.
Okay.
Oh, okay, sir.
23, then 28. Okay, just confirm the roll numbers. Okay, roll number 1, 2, then 3. Okay, roll number 5 absent, 6 absent. Roll number 5, 6 absent. Then roll number 10 absent. Then roll number 15, 16, 17. 15, 16, 17 absent. Then 19, 20 absent. 19, 20 absent. 21, 22 absent. 22, 23 absent. Hello?
Sir, 23 present.
Okay, 23 present. 23. Okay, 23 present.
23.
22.
20 present, sir.
20 also present. Okay, so
20 also present. Yes, sir.
20 present. 22 present. 22.
22.
22 present or absent? 22. Okay.
Present. Present.
Okay, then 24. 24.
Present.
Present.
Sir. Yes, sir.
Okay, 24 present. Okay. Okay, then 23 present. 23.
Yes, sir.
Okay, then 27 absent. 27. 27 absent. 27 absent. Okay, then 29 absent. 29 absent.
Present, sir. Present.
29. Okay, to Achumi.
Yes, sir.
Your roll number 29.
Yes, sir.
Okay. Okay, then 31
Yes,
present.
sir.
Okay. Then 31 absent. Then 34 absent. Then 36 absent. 37 absent. 38, 39 absent, then 42 absent, then 44 absent, then 47 to 40, 47, 48, 49, 50, all are absent.
49 present, sir. 49.
49 present.
Yes, sir. Because of net issue, sir, I can hear anything.
Okay, 49 present. Okay, so 1, 2, 3, 4, 5, 6, 7.
Roll number 19.
Oh, yeah, 19, I know that. 19 present, I know.
Sir, 21.
Okay, all of you have got the attendance, okay? Roll number 5, 6 absent. Okay, so I will ask you once again. 5, 6 absent, then 15, 16, 17 absent, then 24, 27 absent, then 31 absent, 34 absent, then 36, 37, 38, 39, all are absent, then 42 absent, then 44 absent, then 47, 48 absent, and 50 absent. Okay. Okay, so next, can you see the PDF? Can you see my screen? Can you see my
Yes, sir.
Okay. So next, let us see the thermal expansion of concrete. Okay, so in the last class, I think I told you why steel is used in concrete. Is it? Okay, so now you can see the thermal expansion of concrete in the PDF. Okay. This clause number, whatever is mentioned in the PDF, you can write the clause number. Okay, you can write the clause number and you can go to IS, this one 456. As you can go to clause number 6.2.6, then you will see the thermal expansion of concrete. Okay. Next is a very important property which is known as workability. Okay. So workability, you see here, it is the property which determines the ease and homogeneity with which concrete can be mixed, placed, compacted, and finished. So this property is known as workability. Okay. So if your concrete is workable, then only we can use that concrete for any construction. Okay. So next one line is written here: a workable concrete will not have any segregation or bleeding. Okay. So now can anyone tell me what is the meaning of the word segregation or segregate? Can anyone tell me the meaning of the word segregate? Okay, so
I think, sir,
yeah,
I think segregation is like a small partition.
segregation is nothing but separation. Okay, so segregation, how can you understand? That means, say I will give you 1 rupee, 2 rupee, 5 rupee, and 10 rupee coins in a container. Okay, so I will give you, say I have given you some coins of 1 rupees, 2 rupees, 5 rupees, and 10 rupees. Okay, and I put all the coins in one container, and I just told you to segregate the coins. Then what you will do? You will take out 1 rupees coin separately. You will take out 2 rupees coin separately. You will take 5 rupees coin separately, and you will keep 10 rupees coin separately. Okay. Then after taking out all the coins separately, then you can say that I have segregated all the coins. Okay. So similarly, in concrete also, if the various constituents of concrete, that means cement, sand, and aggregate, if they are separated from each other, can you tell me whether we can use that concrete or not? If after all cement, sand, and aggregate, if you see all the constituents are separated from each other, then can we use that concrete?
Sir,
Yes or no?
No, sir.
No, sir.
No. Okay. Why no? Because every constituents are separated. So if you use that concrete, you will not get the desired strength and your structure will fail. Okay. So what might be the reason for segregation? What might be the reason? Can you guess the region? Anyone? Can you guess the region?
Sir, less amount of water.
Yeah. If you put less amount of water, then after mixing, you will see that all the constituents are separated from each other. Okay. So next one term is here, which is written as bleeding. Can you see in the PDF bleeding? I have highlighted the portion bleeding. This term.
Yes, sir.
Okay. So now can you guess what is bleeding?
Flowing. It's like flowing.
Can you guess what might be the meaning of the word bleeding?
I think, sir, it's flowing, I guess.
It is.
Flowing.
Okay, bleeding means say, see, just take the example of if you cut your hand, then what will happen? Blood will come out, is it?
Yes, sir.
Okay, so similarly in concrete, if you put excess amount of water, then what will happen? After mixing, what will happen? If you put excess amount of water, then after mixing, what will happen?
It will overflow.
Yeah, overflow means that water will take cement and sand with it and it will flow out, is it? Yes or no?
Yes, sir.
If you put
Yes,
extra
sir.
amount of water, then that extra water will take cement and sand with it and it will flow out of the concrete, is it? So if
Yes, sir.
you use that concrete in your